Today, the topic that we are going to cover is the significant figures in product. So we have to study significant figures in product, division, and power. Last time we studied the rules for significant figures for plus and minus. Now today we have to study the rules for product, division, and power. Now, answer of product, division, and power will depend on the least significant data. Students, whatever I'm writing, you have to copy it with me. Now, first of all, rules for significant figures in product, in division, and in power. Secondly, we must know that when you write answer of a certain product, division, or power, then the answer depends on the data set which is least significant. And the rule is that the significant figures in the answer will be either equal to the least significant data or one significant figure more than the least is allowed. So basically, when you multiply two numbers, you divide two numbers, or you go for power of a number, then the significant figure of the answer should be according to the least significant data. Now, what is the rule? The answer should be there whose significant figures will be either equal to the least significant data, or they will be equal to, or they will be one more than the least significant data. Now, for example, if we write data and significant figures of the answer. So for the given data, what would be the rules for the significant figures? Number one, let's suppose you have to multiply 2.3. It is, just for example, it is length. And the width is, just for example, 5.000. And the height is, just for example, 12397. Now you have length, width, and height. And generally, you know, length is greater. However, in this question, you have different values for length, width, and height, and they are by convention, just for example. Then you see, the question is about multiplication. Basically, forget about length, width, and height. You have three numbers which are to be multiplied: 2.3, 5.000, and then you have 12,397. 2.3 has two significant figures. 5.00 has four significant figures. And 12,397 has 1, 2, 3, 4, 5 significant figures. Now, out of all of them, which one is least? Obviously, two significant figures is least significant figures. Now, by principle, the answer can have either two significant figures or it can have three significant figures. As one significant figure extra is allowed. So when you multiply these three numbers, the answer should have either two significant figures or it should have three significant figures. It will follow the least significant data. Now, second example. Purpose here is not multiplying or getting the answer. The purpose is to understand the rules for significant figures when you multiply numbers. Now, let's suppose you have to multiply some values to get an answer. A 20x is calculated by multiplying, let's suppose, 2.45 into 12, and it is divided by 8. And these are the three data values. Now you see 2.45 has three significant figures. 12 has two significant figures. And 8 has one significant figure. Now, out of all the numbers, 8 is the least significant data. So significant figures of the answer will depend on the least significant data, that is 8. So we can say that the answer can have either one significant figure or two significant figures are also acceptable. So in case of multiplication, power, and division, either you follow the least significant data or you write one significant figure more than the least significant data. Here, if you write one significant figure, then it is equal to the data value with least significant figures, and that is 8. So the answer, if you write one significant figure, then you are exactly following the significant figures equal to the least significant figures. If you write two significant figures, then you're writing one significant figure more. Then you're writing one significant figure more than least. So you will either write significant figures equal to the least significant data, or you'll write one significant figure more. Now, what are the conventions and rules, typical conventions about significant figures? Let's look for the conventions. Conventions and rules for significant figures. Conventions and rules for significant figures. There are some conventions and rules that you have to understand. First of all the digits from 1 to 9. When we say all the digits from 1 to 9, we mean non-zero digits. When we say all the digits from 1 to 9, it means non-zero digits. So all the digits from 1 to 9, that is non-zero digits, are always significant. So one thing is that all the digits in a number from 1 to 9, which are non-zero digits, they are always significant. They are always significant. Zeros present in a number may or may not be significant. So it is the zeros which are ambiguous or which are to be studied whether they are significant or not significant. However, digits from 1 to 9 are out of debate. They are present in a number when they are given by an instrument. So all the digits from 1 to 9, which are called non-zero digits, they are always significant. They can never be insignificant because they are always given by the instrument. It is a zero which are sometimes applied while converting the unit. So when you convert a bigger unit into smaller unit, you apply some zeros. So zeros may be significant or they may not be significant. What are the conventions? When you take zeros significant and when you take them to be insignificant, or what are the conventions that you use to mention whether a number contains significant zeros or insignificant zeros? Now we will study the rules one by one. Number one, zeros which appear before a non-zero digit are always insignificant. So the zeros which appear before a non-zero digit, they are always insignificant. And what is meant by before? Basically, we are saying that zeros on the left of a non-zero digit are insignificant. So all the zeros that appear before a non-zero digit, they are insignificant. For example, we have studied two rules. The first rule is all the digits from 1 to 9 are significant. They are always significant. Zeros present in a number may or may not be significant. And the first thing about zeros is the zeros which appear on the left side of a number or before a number, they are always significant. This is the rule. Now, what about, let's give some examples for that. Let's give some examples for zeros that are present before a number. Now, let's suppose you have a number 0, 0, 0. You have a number 0, 0, 0. And then you have a number 0, you have a number 0, 0, 0, 1, 2, 4. Let me clear the notebook first, then we will move on. You have, according to the following example, you have a number 0, 0, 0, 1, 2, 4, 8. Now, the principle is that these three zeros, they are insignificant. Now, if you ask the reason, why are these zeros insignificant? The reason is that insignificant as they are before or on the left of a non-zero digit. This was a number without a decimal point. Now let's suppose you get a number with decimal point, and what would be the rule for zeros in that number? You have 0.000125. What is the rule for these zeros? So the zeros which are before a non-zero digit, they are always insignificant. So they are meaningless. Basically, these zeros are in a number to determine the place values of first non-zero digit. So these zeros are always insignificant as they are on the left of the first non-zero digit. Here I may ask a question. If I ask you, what is the purpose of these 3 or 4 or 5, whatever zeros? What is the purpose of these 5 zeros? The purpose of these 5 zeros is, as far I can understand, The purpose of these 5 zeros is to determine the place value of this 1. So if we remove these zeros, remove these zeros, what will happen? Just for example, if these zeros are removed, the only thing that is the problem is that the place value of this 1 will change. So the zeros on the left of a non-zero digit are only there to determine the place value of the first non-zero digit. So for the sake of understanding, you must know that if you have a number 0.000547, then actually these zeros are not significant. Basically, you have to treat them as 0. dash 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 547. So these places, they have no place value and they are just there to give a place value to 5. So if I ask you what is the purpose of these dashes, then these dashes are first dash, second dash, third dash, is to tell that fifth is the 4th decimal. Now, if we put in, instead of dashes, if we put zeros, 1, 2, 3 zeros. If these 3 zeros are not there, then the place value of 5 will not be clear. So because of these 3 zeros, place value is of 5 is the 4th decimal. So the purpose of these 3 zeros is to determine the place value of the first non-zero number, that is 5. So in simple words, if you get zeros before a number like these zeros, then these zeros are there. These zeros are to tell that in the given unit, here what is meant by given unit, maybe your number could be in amperes. So given unit is amperes. So these zeros are there. Zeros are these zeros before a number are to tell that in the given unit, first non-zero digit, that is 1, 1 is at 4th decimal place. So in the units of ampere, the first one that you have, it is there at the 4th decimal. Okay, sorry, it is at the, I think, 5th decimal, not 4th decimal. So the first one is at the 5th decimal, and the zeros, 4 zeros are there to tell that 1 is at the 5th decimal in the units of ampere. That's why these zeros are not significant. Just for example, if you convert unit, if you write this number from ampere to milliampere, 0.00001247 ampere, if you convert it to milliampere, then you have to multiply it with 1000. Now let's suppose you multiply this number with 1000, then it would become 0.01247. Now you see the zeros have been eliminated by converting the unit. So the zeros which are eliminated by converting the unit, they are never significant. Significant zeros can never be eliminated from a number. They will always be here. Here, when you convert the unit, the zeros have been eliminated, so the zeros are insignificant. That's why we say that the given zeros before a number, they are always insignificant. They are meaningless. They are just there because of a wrong unit being used. If you change the unit, the zeros are, you see, they are eliminated. So they are to give the place value to the first non-zero number. Now this is the rule for zeros which are before a number. Now zeros which are after a non-zero digit. Second rule, if zeros are present, between two non-zero digits, then they are significant. Now, if you get some zeros which are present between two non-zero digits, then those zeros are always significant. Let's suppose you have a number 5001247 How many significant figures are there? Now here you have 1, 2, 3, 4, 5, 6, 7, 8. It has 8 significant figures. Now here the zeros are, these two zeros are, they are significant because they are between two non-zero digits. They are given by the instrument, and even after the conversion of unit, they will not be eliminated. Now these zeros are significant. You have a number 5.000125. Now what about these zeros? You see these zeros appear, these three zeros, they appear between non-zero digits. So these three zeros are significant. Whenever you have zeros which are between non-zero digits, they are always significant. And as a result, how many significant figures are there in this number? 1, 2, 3, 4, 5, 6, 7. So the given number has 7 significant. So the given number has 7 significant figures. So the given number has 7 significant figures in it. So the zeros are significant. So when you have zeros between two non-zero digits, they are significant. Now rules for zeros which are on the right of the digit, right of a digit. First of all, by convention, if the number has no decimal point, and it's very important. If a number has no decimal point, then zeros written on the right hand, then zeros written on the right hand side of non-zero digits will be insignificant. So if the number has no decimal point, then the zeros which we write towards right hand side of a non-zero digit, they are insignificant, and their reason is using a smaller unit. Now let's suppose if you have a number 5,000 milliampere, you see there is no decimal point in this number. The number has no decimal point, and 3 zeros are on the right of this non-zero digit. Now what is the principle? By principle, these 3 zeros, they are insignificant, which means that they were not given by the instrument. Now if you convert unit to ampere, then this current would become 5 ampere. So these zeros which are on the right of a number, they are insignificant because the number has no decimal point. So if you write zeros on the right of a number without putting a decimal point, then the zeros are insignificant. Now if you get some zeros in a number on the right hand side and the number has the decimal point, if the number has a decimal point, then zeros on the right hand side are always significant. Now if you get decimal point in the number, then zeros on the right hand side of non-zero digits, they will be significant. Let's suppose you have a number 50.000. Now you see you have a decimal point. Now here you have a decimal point. Now because of this decimal point, all the digits, all the zeros are significant. All these zeros were given by the instrument, so all of them are significant. So the zeros that you write in a decimal point number on the right hand side, they are given by the instrument, otherwise you will not write them. So when you put a decimal point, all the zeros on the right hand side of a number will become significant. Let's suppose you have a number 5,000.0. Now because of this decimal point, you see here you have a decimal point. So whenever you see a decimal point, the zeros on the right side of the number, they will become significant. So these zeros, they are, all of them, they are significant. So the zeros that you wrote on the right hand side of the number, they are significant here. Now let's revise rules in one go. You have to tell the significant figures of a number, and then you have significant figures. Now let's start. Just for example, if you have a number 1, you have a number 0.000 1, 2, 5. Now, the digits which are significant should be ticked and the digits which are insignificant should be crossed. Non-zero digits, they are always significant, and zeros on the left side of a number, they are insignificant. So here you have 3 significant figures. The zeros are not significant. Number 2, you have a number 0.000125 and then 2 zeros. Now you get a decimal point. When you get a decimal point, the zeros which are after non-zero digit, these 2 zeros are on the right side of this non-zero digit, they will become significant. So because of this decimal point, the zeros which are on the right hand side of a non-zero digit, they will become significant. And one thing, zeros which are on the left hand side, they can never be significant. So zeros which are before a non-zero digit, or you can say that they are on the left side of non-zero digit, they can never be significant. So here you have 1, 2, 3, 4, 5 significant figures. So this number has 5 significant figures. These are the digits which are significant. Rule number 3, you have a number 1, 2, 5 and triple and tetra 0. 1, 2, 5 tetra 0, and you see the number has no decimal point. The number has no decimal point. Now by principle, if decimal point is not present, then zeros which are following the non-zero digits will be insignificant. So zeros which are after non-zero digits or on the right side of non-zero digits, these 4 zeros, they will become insignificant because the number has no decimal point. So how many, they should be crossed. They are insignificant. Now these 3 numbers are significant, and this number has obviously 3 significant figures. Example number 4, if you have number 5000125000. Now you see you have some zeros between, first of all the number has no decimal point. This number has no decimal point. Now what are the rules? The rules are that these non-zero digits are always significant, and the zeros present between 2 non-zero digits which are in between, they are always significant. The zeros which are on the right side of non-zero digits are insignificant if the decimal point is not there. So in total it has 1, 2, 3, 4, 5, 6, 7 significant figures. So this number has 7 significant figures. Example number 5. You get a number 500.00. Now a decimal point is present, as you can see. When a decimal point is present, then zeros following the non-zero digit will become significant. Now all of them are significant, and the number has 5 significant figures. So these zeros will become significant. Rule number 6, you have a number 5000 and you put a decimal here. When you put a decimal here, just for example, if you write 5000 without decimal, if you write it with decimal, even if there is nothing after the decimal, still the decimal has impact. When you put a decimal, you are telling that these 3 zeros, they were noted by the instrument and now they are significant. Now they are significant. Now this number has 4 significant figures. And this number, in this number, these zeros are not significant. They were not given by the instrument. Only 5 was given by the instrument. So when the number has no decimal point, the zeros which are present, they were not given by the instrument. And as a result, this number has obviously 1 significant figure. So these are common rules for significant figures. In the next class, we'll write conventions for operators. Plus, we understood it. Now we are writing the notes. In the next class, we'll start from this point. Take care, students. Khuda Hafiz.